In today's demonstration we're going to see the effect of voltage reduction on electronic ballast fluorescent lights. We have 4 new units here today, each rated at 36 watts per 230 volts, and each one, as I mentioned before, are run on the latest electronic ballast. Many people believe that the reduction in voltage does not affect these types of electronic ballast fluorescence lights. This demonstration is going to provide evidence that shows it actually does produce significant savings. I'm now going to switch the electronic fluorescent lights on. And we're going to have a look at one of our workshop prop savers running and controlling the voltage on this load today. You'll notice that we have flashing in the window the current voltage supply to the electronic ballast fluorescence, and you'll notice that at 242, an average voltage for the UK, these particular lights are pulling 0.675 amps and 104 watts. I'm now going to drop it down to 220 volts, which would be the output of the prop saver single and 3-phase system, and of course the newly developed light saver. We're now seeing, with the voltage reduced to 220 volts, we have a reading of 0.653, 0.654 amps, and the amps have gone down to 92. So there is a significant reduction, around about 9% reduction in actual power usage. I'm now going to bring the voltage down on the prop saver to 210 volts, which is an optimum level on the single phase prop saver, and of course with the light saver we can reduce this down right to 195 volts. So let's have a look at the power output at first 210. And we see another significant drop down to 87 watts, 0.64 amps. Now I'm going to drop it down to the magic 200 volts. And we can see another drop in the watts and the amps. And I'm going to put it now at the lowest recommended setting for warmed units, about 20 minutes worth of mains power before they're reduced down to the lowest level of 195, which is available in the light saver. And we see we're now down to just about 80 watts in over 20% saving. Of course, with any lights, a reduction in voltage means a reduction in lumen output. We're now going to examine what the lumen output is and how it's reduced with the relevant reduction in volts. We're now going to examine the relationship between the reduction in voltage on the electronic ballast fluorescent tubes versus the reduction in lux, i.e. light output. The prop saver now is providing 242 volts to the fluorescent lights, and we can see, as before, the amperage 0.669 amps and 103 watts. The voltage on there is an average voltage for the UK. A Lux machine is showing about 400 and rotating between 400 and 401. So we'll take the 401. We'll now reduce the voltage to the fluorescent tubes down to the output of the prop saver 3-phase and single phase, which is 220 volts. And we'll then be able to see not only clearly a reduction in power. It's now gone down to 0.643 amps and a reduction in wattage to 91. We're now at 220 volts and our lux meter is showing 355. That means that a reduction of about 11.4% in lux has given us a saving of about 8.75 on wattage. So for 8.75% reduction in power, we've got a reduction of about 11.4% in lux. This reduction of about 11% is almost imperceptible. However, let's continue down. Let's now bring it down to the next voltage level, which is 210 volts. 210 volts is the optimum power setting for the prop saver single phase. We now see that at 210 volts, again, the amperage has gone down to 0.634, and our wattage, of course, has also reduced down to about 86 watts for the prop saver single phase. We now see that at 210 volts, again, the amperage has gone down to 0.634, and our wattage, of course, has also reduced down to about 86 watts. Also, our lux meter is now showing 334 lux, so that's times 10, 3,340 or 3,350 as it's now reading. That's a 16.8% reduction from the original setting at 242 volts. It is also a massive 17.5% saving from the original 242 volts. Now, I'm now going to go down to the lowest setting, which is found on the light saver, which is 195 volts. And let's look at the relevant reductions. At 195, you'll see the lights are operating perfectly well. I don't think you'd be able to pick up any change in brightness. It is almost imperceptible, but there is a drop in lux. Meter now is reading about 305, that's 3,050 lux, which represents about a 22% loss in light from the original 242 volt setting, but also a 23.3% reduction in power. So this example today demonstrates quite clearly that there are substantial power savings to be made when one uses even the best electronic ballast fluorescent lights.